We continue review calculus 1. We have a bunch of integrals. On this integral, we're going to use substitution. So two important things in substitution. We need to know what is u, and then we need to solve for dx. Once again, u and then dx. So for the first problem, I will let u equal to x to the 6 plus 4. And then we can check derivative. We use du over dx as the notation. Derivative x to the 6, 6x to the 5th. And then we can multiply both sides by dx and then divide by 6x to the 5th. 6x to the 5th dx. We can see x to the 5th and dx already. But I'm just going to solve for dx. So we have du over 6x to the 5th equal to dx. And that will be dx. So any substitution problem, we should have u and then dx. Then we can substitute back into our problem. X to the 5th stay there, and then we have square root. X to the 6 plus 4 is going to be u, and then dx replaced by du over 6x to the 5th power. Right? Now, if everything works out perfectly, there will be no more x, and as we see the x to the 5th cancel out. We have 6 here as a constant. I will write that outside of the integral, but it will be at the bottom because it stayed at the bottom originally. I'll put 1 on the top, and then just square root of u du. So 1 over 6. To integrate square root of u, I will write u to the 1/2 du, and applying power rule for u to the 1/2, increase the power by 1. 1/2 plus 1 is 3/2, and then divide by the same thing, 3/2 plus c. Now divide by 3/2 is multiply the reciprocal, 2 over 3. And then u to the 3/2 plus c. 6 and 2 cancel out. That's 3. So 1 over 9 u to the 3/2 plus c. And finally, substitute back in for u. U is x to the 6 plus 4 to the 3/2 plus c. As you see, pretty standard. So whatever we let equal to u, when we take derivative, it should cancel with what is left of the problem. So the problem has x to the 5th, so that should cancel out. Whatever we let equal to u, the derivative should somehow have x to the 5th in it. So that's the first one. Right. The next one will be similar. Choose u to be something, and if we let u equal to 7x squared plus 3, derivative of this is 14x, and the x should cancel with the x on the top. So that's a good substitution. We should be able to see that. But usually when we see this integral, I will prefer to put the dx on the way on the back, like that. Now, substitution. Let u be 7x squared plus 3 and then we take derivative, because when we take derivative we can solve for dx. So du over dx 14x multiply the dx, du equal to 14x dx, and divide by 14x. So du over 14x is dx. So we continue. X will stay there. 7x plus 3, that's going to be u. 7x squared plus 3 is going to be u, still to the 5th power. Dx is du over 14x. That works out perfectly. This x cancel that x. The 14 constant, bring it outside, and it stay at the bottom. And then we have 1 over u to the 5th power du. Right. To integrate that, we write u to the negative 5 du, and integrate 1 over 14 u to negative 5 plus 1 is negative 4 divided by negative 4. So that's just the power rule there, and then plus c. Right, multiply straight across. 14 times negative 4 is negative 56, and then u to the negative 4 plus c. So negative 1 over 56 u to negative 4, u is 7x squared plus 3 to negative 4 plus c. So that's what we have. Again, we need to have u and need to solve for the x, and when we substitute in, everything cancels out, works out perfectly when there's no more x in the problem. Right. Times them. Next, same thing. Need to have u and need to solve for dx. Let u equal to 3x minus 2, and we take derivative. Give us 3, multiply dx and divide by 3. So du over 3 is dx. Right. And then substitute sine, and 3x minus 2 is u. Dx is du over 3. Factor out the 3. Stay at the bottom though. One over 3 sine of u du, and then integral of sine u is negative cosine u. Plus c. So that gives us negative 1 over 3 cosine of u plus c, and u is 2x minus 2, so negative 1/3 cosine of 3x minus 2 plus c. So that's what we have. Right. So more substitution. On this one, remember whatever we let equal to u, when we take derivative, we cancel with the rest of the problem. Now if we let u equal to 5 plus cosine of t, derivative of cosine is sine t, which will cancel with this sine. Right. So let u equal to 5 plus cosine of t. We'll take derivative. Will be negative sine t multiply the dt and then divide by the negative sine t. So we have u, and in this case dt. That is ready for the substitution. Sine t stay there. Bottom we have 5 plus cosine t is going to be u to the 4th power. Dt is du over negative sine t. Notice that is not subtract, it is multiply here. So the sine t can cancel with the sine t. This negative sign, I will take it outside. I just put that negative. And we have 1 over u to the 4th power du. Right, integral of that, let's rewrite that as u to the negative 4 du, and integrate u to the negative 3 over negative 3 plus c. So power rule, increase the power by 1, then divide by the same thing. Right. Now negative and negative, so that is 1/3. And not only that, I'm going to move the u to the negative 3 to the bottom, become u cubed plus c. And finally, just substitute back in for u, 1 over 3. U is 5 plus cosine t cubed plus c. So that's what we have for that one. Next we also use substitution, but for definite integral, so there will be a limit. Not much different here. We still have u, and then solve for dx. Derivative is just 1, and we multiply over, so du is dx. Right, so we have those two. Now the difference of this one with the problems that we did is that this one has the limit. Originally it is the limit for x, so we can say x equal to 0 to x equal to 1. Originally the limits are for x go from 0 to 1. X equal to 0 to x equal to 1. When x equal to 0, put 0 in for x. We have u equal to 0 plus 4, so it's 4. And when x equal to 1, 1 plus 4 is 5. Right. Then we have the integral. The limits become u equal to 4 to u equal to 5. And then square root of u, and dx is just du. Right, and then we just integrate. So u equal to 4 to 5, u to the 1/2 du. So integrate 1/2 plus 1 is 3/2 over the same thing as a power, and then go from 4 to 5. Notice that on this form we change the limit from x to u, so now we have u and we just have the limit for u. We don't need to substitute back in for x anymore. So 3/2 divided by 3/2 is multiplied by 2/3. And then we're going to put 4 into it. Substitute the upper limit. That we cannot do anything. And then 2/3, put in 4 to the 3/2. Right. We can stop there. But if we want to go a step further, here what we can do. I'm just going to write that here. 5 to the 3/2 is like 5 cubed, square root of 5 cubed, which is square root of 5 and square root of 5 square, or 5 square root of 5. And 4 to the 3/2, so 4 cubed, and then that. 4 cubed is 64, so we have 64, so it's 8. So if we want to, we can evaluate using those numbers. So 2/3 times 5 square root of 5 minus 2/3 times 8. So that gives us 10 over 3 square root of 5 minus 16 over 8, 16 over 3. On the test, you can just stop here. It's perfectly fine. Don't use the calculator and get approximation, because that is not going to be any nice number. Right. Next one is also substitution. So when we look like this, it's kind of difficult to see what is the actual substitution. But if we rewrite the cosine square as this, so that is the integral equal to. Now instead of write cosine square, forget the timestamp. So 3, I will write cosine square as cosine of x, and then square, and then sine x dx. When we write like this, it is easy to see that if we let u equal to cosine, derivative of cosine is negative sine, we cancel with the sine. So that's good. Whatever we let equal to u, the derivative will cancel with the rest of the problem. That's the way it should be for most of the substitution. So we let u equal to cosine of x. Right. Don't forget there's a limit here, pi over 3 and 2 pi. Right. So u equal to cosine of x, take derivative. Cosine is negative sine x. This is the derivative, not integral. Multiply dx over negative sine x dx. And then divide. Now the limit. Originally the limit for x equal to pi over 3 to 2 pi. Now we will write the limits. X equal to 2 pi. U equal to cosine of 2 pi. Cosine of 2 pi is like cosine of 0, which is 1. And then when x equal to pi over 3, u equal to cosine of pi over 3. Cosine of pi over 3 is 1/2. Right. So we change the limit from x to u. And that definite integral becomes, the limit now is u is 1/2 to u equal to 1. And then 3 cosine of x, that is u, and then square sine x, stay there, and dx is du over negative sine x. Again, it is multiplied to it. Sine x cancel out, which is always a good thing when we cancel all the x. 3 is a constant, bring it outside, and negative, bring it outside. So we will have negative 3 on the outside. Limits 1/2 to 1. And then we have u square du. Integral of that is negative 3 u cubed over 3. Just standard power rule. And then go from 1/2 to 1. Once again, we did change the limit from x to u. So now we have u and we have the limit for u. Perfectly fine. Don't need to go back for x. Cancel out. We have negative u cubed going from 1/2 to 1. Now, we will substitute in negative 1 cubed and then subtract negative 1/2 cubed so give us negative 1 minus the negative, so that's a plus. 1/2 cubed is 1/8, so that gives us negative 7 over 8, and that's what we have. Alright. Next, this is the inverse function theorem. The inverse function theorem. So if we have the inverse with respect to y, and we want to take derivative of that, then it will be equal to 1 over derivative of x. Notice that originally it is y, and then we take derivative, it is x. So that is the inverse function theorem. Alright, so we just do that. So we write the derivative of the inverse as a function of y equal to 1 over derivative of x. Right. Derivative of this is easy. We have 1024 times, so that will be equal to 1 over 5 times that is 5,120 x to the 4th power. Right. So pretty much that's what the theorem tells us. Now, but here's why we should change the variable back to the same thing. So I will do that on this side. Originally, I will write y equal to 1024 to the fifth. Now we need to solve for x to the fifth. So divide by 1024. And then if we divide by that, and then we take the fifth root, we will have x equal to we just raise both sides to the 1/5 power. So we say y over 1024 to the 1/5. Now that 1/5 will go to the top and goes to the bottom. 1024 to the 1/5. Right, let's see. Uh, 1024 to the 1/5. So that's 4, right? So we have y to the 1/5 over 4. Right, so that is x. We're going to substitute into this x. So that is 1 over 5120. And we have y to the 1/5 over 4 to the 4 power. So going to be 15120. Y to the 1/5 times 4. I mean the power 4 go to the top, go to the bottom. Go to the top, we have y to the 4/5. And at the bottom 4 to the 4 power. That is 256, but so we have 4 to the 4 power 256, and then let's just write 256, and then 5120 divided by 256, we have 20. So this end up with 1 over 20 y to the 4/5. Right, so we have y and we end up with y. So we have to start with y and we end up with y, which is good. If we want to write the answer, we just need to change this x and that into x. So the answer will be derivative of the inverse function. If we choose x as a variable instead of y, then we're going to change this to x, and we have 20 x to the 4/5. So that is inverse function theorem. Right. Next we just have derivatives. Derivative of the logs, and then derivative of exponential function. But first, the timestamp. Right. We take derivative of this. So derivative of ln is 1 over x. Right, so that is the derivative rule for ln of x. Right, so here if we put a bracket around this, we take derivative using the chain rule. Derivative of ln of something is 1 over that bracket, and derivative of that bracket doesn't matter what it is inside. And inside we have 2x squared so that is 1 over 2x squared and derivative of 2x squared is 4x. And 4x on the top, 2x squared at the bottom, cancel the x and the x, the 4 and the 2, we have 2 over x. Right, so that is one way to do it. Or if we take advantage of the properties of the log, we can also do this. Y equal to ln of 2x squared. It is the product. So we can turn that into a sum. Notice we haven't taken any derivative yet. We just rewrite the function. So here, just quickly write the rule. Ln of m times n is ln of m plus ln of n. And then next, there's also another rule. We can take the power outside. Again, that's not derivative. It's just the properties of the log. I should say natural logarithm. And then when we take derivative, it will be very easy. That is a constant. Derivative will be 0. And ln of x derivative is 1 over x. So we just have 2 over x. So if we use the properties of the log, we do it this way. We don't have to use the chain rule. Or if we just use the chain rule, it will be that. The next problem, I want to take advantage of the property of the log, because using the quotient rule for this could be unnecessary. Right. So what we do is first, there is a quotient. We'll turn that to a difference. Just say this is dy, this is dy, this is derivative. Right. So still y, ln of 1 plus square root of x. Subtract ln of x to the 4th power. Right. Of course, the 4th here we can take it outside. I will rewrite. First, let's just write the properties of the log. Ln of m divided by n is ln of m minus ln of n. Right. Now we will write a little bit still the function. I will write square root of x as x to the 1/2. And do take the 4 outside. So write like that. Right. And then we'll take derivative. Now derivative, there's no choice. We cannot break this out any further, but we're going to use the chain rule. ln of something is 1 over that thing, and then time derivative. That's the standard for chain rule. Derivative of ln of x is 1 over x. Then we have in the parentheses 1 plus x to the 1/2. And then 1 plus x to the 1/2. Right. Derivative of 1 constant is 0. Derivative x to the 1/2 is 1/2. X to the negative 1/2. And then we still have 1 plus x to the 1/2 minus 4 over x. Right. And then we will rewrite this. First, x to negative 1/2 move to the bottom. Right. Let's do this first. On the top, we have 1 over 2 x to the 1/2. So that is just the top. And we take the top on the outside, and we still have 1 over 1 plus x to the 1/2. And then minus 4 over x. Then put multiply straight across, we will have 1 over 2 x to 1/2. Let's write square root of x, and then 1 plus square root of x minus 4 over x. We're going to stop at that step because that is the derivative. Right, times 10. Right, next we have derivative of exponential function. This is easy. E to the x derivative is still the same thing. Right, now the function is that. Let's rewrite the function. Negative 8 e to the 3x. If we put all the exponent in the parentheses, and then we take the derivative using the chain rule. Negative a is constant, we stay there. Derivative of e to something is just e to the same thing, and then derivative of that inside the parentheses happen to be 3x. So we have negative 8 e to the 3x. Derivative of 3x is 3, and then 3 times minus 8 is negative 24 e to the 3x. Right, so that's all we do. Right. Next, this is also exponential rule, but we're going to use the product rule here because it's clearly a product. U, V. Let u equal to 4x squared. Derivative is easily done. Ax. V is e to the negative x. Derivative of that, I will use the chain rule. E to the same thing. Derivative of that. Derivative of negative x is negative 1. So we have e to the negative x times negative 1, or just negative e to the negative x. I might take more steps than it should, but that's right. So that is the original function. Now we will take derivative. I don't write e equal, that's why I write the arrow instead. So it cannot be equal because that's the function. This is the derivative. Right, derivative of the product. Product rule, u prime v plus uv prime. U prime ax v e to the negative x plus u 4x squared v prime negative e to the negative x. Right, multiply it out. Ax e to the negative x and minus 4x squared e to the negative x. It would be better if I just factor out the e to the negative x. Usually we just need to factor out e to negative x and not factor everything out completely. So it's much better just leave the answer in that form. Right. Right. Next we have the find derivative of 2 to the square root of t. Right. So we're going to put the parentheses around. Let's just rewrite that first. 2t to the 1/2. and we'll put all the exponent in terms of t, and then we'll take the derivative of that. So derivative is going to be the same thing, but we have to multiply by the base, ln of the base. So derivative of b to the x is ln of b times b to the x. So we just have to have the ln of the base 2 and then pretty much the same thing. And then derivative of whatever inside the bracket. So that is the chain rule. Right. So ln of 2, then 2 to t to the 1/2. Derivative is 1/2 t to the negative 1/2. We cannot do anything, cannot combine any of this, because the 2 raised to that power and the 1/2 is a constant. So just write what we can here. ln of 2 will stay on the top, the 2 to the t to the 1/2 also on the top, the 2 at the bottom, and t to negative 1/2 if we move to the bottom, t to the 1/2. We can change this to the 1/2 power, but there's nothing cancel here, so I should just stop there. Right. Next we have integral using substitution. First, as always, when we have the dx on the top, I just write that on the side. That will be better. I prefer to have the x on this side. Right, and then substitution. Let u be 1 minus 2x. And then we take derivative. du over dx equal to derivative of that, which is negative 2. Multiply the dx and then divide by 2. So that's the standard substitution. So we have 5 on the top, u at the bottom. Dx is du over negative 2. The 5 is constant. Take it outside, stay on the top. Negative 2 at the bottom. We'll go outside, but at the bottom. So we have 5 and negative 2 on the outside. Inside the integral, we just have 1 over u du. Now that's easy. The integral of that is ln of absolute values of u. So we will have negative 5/2 ln absolute values of u plus c. So negative 5/2 ln, and u is 1 minus 2x plus c. Right. The next one, we'll also use substitution. First, let u equal to the exponent here, because when we let u equal to that, derivative is negative 7x to the 6, which cancel with this x to the 6 here nicely. So let u be negative x to the 7 power. Then take derivative. Negative 7 x to the 6, multiply the x, and then divide by 2. So 7 x to the 6 plus 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 7 and divide by that. So this integral will be equal to x to the 6 and then e negative 7 negative x to the 7, that is u, dx is du over negative 7 x to the 6. So we have x to the 6 we done a bunch of this problem and still didn't get the routine done. X to the 6 cancel out, negative 7 take it outside, negative 7 will be at the bottom, 1 on top. That equal to e to the u du. Integral of that is easy. Derivative and integral of e to the u is just e to the u, except for the integral. There was plus c. And then u is negative x to the 7 plus c. Right, so that's what we have. Right. There are more. Right. Now this one. Let's see. If we let u equal to secant, derivative of secant is secant and tangent. Doesn't look like that will cancel with this. Now if we let u equal to sine of 4x, derivative of sine is cosine. Potentially can cancel with the secant because the cosine and secant are reciprocal of each other. So it might work. Right, let's see. Right. So let u be 5 sine of 4x. And then we'll take derivative. Du over dx. Derivative of this, we use the chain rule here. 5 derivative of sine is cosine of parentheses, derivative of the parentheses. Right, derivative of sine is cosine. That is derivative, not integral. Right, derivative of that, let's rewrite this as 5 cosine of 4x times 4. That makes 20. So du is equal to 20 cosine of 4x dx, and then divide by that. So we have 5e, and this is u on the top, and then the secant 4x. Right, dx is 20, du over 20 cosine 4x. Right. Of course, not quite cancel yet, but that's fine. We can take the 20 outside at the bottom, the 5 on the top. So we have 5 on the top, 20 at the bottom. Now the integral, let's say e to the u still. Secant of 4x is 1 over cosine of 4x. Because secant is 1 over cosine. And we took the 20 and the 5 outside. We just have the du and the cosine 4x left, which cancel out nicely. So we just have e to the u du. So 5 over 20. E to the u. Integral still e to the u plus c. I should cancel that from the first step. 520 is 1/4. E to the u plus c. And u is that. So 1/4 e to the 5 sine of 4x plus c. Right. Right. Next, it is just substitution, but with the limit. So we have definite integrals here. Right. So let's see. If we let u equal to e to the t, derivative is not going to cancel this. But if we let u equal to 5 e to the t, derivative of that we cancel with the top there, which is good. Right. So let u be 5 plus e to the t, and we can take derivative. Right, so that one. Okay. Derivative of 5 constant is going to be 0. E to the t, still e to the t. Multiply the dt across. Du equal to e to the t dt. And then divide by e to the t. So we have that dt equal to du over e to the t. Now the limits. Originally t goes from 0 to t equal to 1. T equal to 0, I'm going to put 0 in here and then put 1 in there. U equal to 5 plus e to the 0 power. E to 0 power is 1. 1, 5 is 6. And then t is to the first. We cannot do anything, so just say 5 plus e. So that would be the new limits. Right, integral will be equal to, we change from t equal to 0 to t equal to 1, from u equal to 6 to 5 plus e. E to the t is still there. 5e to the t, that is u square. dt is that. Cancel out nicely. 1 over u square is the reciprocal. I should say u to the negative 2. Integral of that is u to the negative 1 over negative 1, going from 6 to 5 plus e. Right. To rewrite this, we should have negative 1 u u to negative 1 to the bottom becomes 1 over u, going from 6 to 5 plus e. So we will have negative 1 over 5 plus e subtract negative 1 over 6. So negative negative becomes positive. So we have negative 1 over 5 plus e plus 1/6. Right, so that's what we have. Next. So cosine, sine, so we have to have one of them is u, because derivative of sine is cosine, derivative of cosine is negative sine, so it should cancel out nicely. However, the cosine of t here on the exponent, so we better let u equal to cosine of t. Then we take derivative. Derivative of cosine is negative sine. Move the dt. And divide by the negative sine t. So we have u, and then we have dt. U, and then substitute for dt. Right. The limits, originally t go to 0 to pi over 2. If t go to pi over 2, u is cosine of pi over 2. Give us 0. When t equal to 0, u equal to cosine of 0 is 1. Right. Now ready to put everything in the integral. Right, now the limits, instead of t, now we go in terms of u from 1 to 0. We have 4 to the power of u sine t, stay there. Dt is du over negative sine t. Cancel out the sine t. The negative here, we'll take it outside. And then we just have 4 to the u du. Right. Here we can use properties of the log here. And that property is if it's negative, if we interchange the limit, we throw in an extra negative. So now interchange the limits. Instead of 1 to 0 to 0 to 1, and original that the minus. When we do that, we change the sign for integral. So that's just that 4 to the u du. Integral 4 to the u is just 4 to the u divided by ln of the base, and that will go from 0 to 1. So if we put 1 in for u, 4 to the first, ln of 4, and then put 0 in for u, 4 to the 0 power, ln of 4. 4 to 0 power is 1, so 4 over ln of 4 minus 1 over ln of 4. 4 minus 1 is 3, ln of 4. So that's what we have. Next we have derivative, and for this we're going to use we could use the inverse function theorem, but I'm not going to do that. Just make things very simple. If y equal to tangent inverse of 4x to the 5th, if we take the tangent on both sides, the tangent cancel the tangent inverse. So we have tangent of y equal to 4x over 5. That's very simple there. Next we will differentiate with respect to x. That's very important, with respect to x. So now let's just differentiate with respect to x. With respect to x. X is a variable. Right. So derivative, now y is not x obviously, so put the parentheses around it. So derivative of tangent y is secant square of the parentheses, and then the parentheses derivative. On the right hand side, derivative of 4x over 5 is just 4 over 5. Right. Now just happen in the parentheses, just happen to be y. So we have y prime. If we want to solve for y prime by itself, we divide by the secant square. So we say y prime, which is derivative of this by the way, is equal to 4 over 5 secant square y. Right. Let's rewrite that as 4 over 5 and then secant of y square. Right. Finally, y is that. So we have secant of tangent inverse of 4x over 5 square. Right. Now just need to simplify the inside the bracket there. Right. Now we have tangent of y equal to 4x to the 5th. We will continue from here. Let's rewrite that again. Tangent of y is 4x over 5 over 5. Tangent is opposite over adjacent. So if we're going to draw a triangle, that angle is going to be y. Opposite to that is 4x. Adjacent to it is going to be 5. The hypotenuse therefore is 5 square plus 4x square. So that will be 16x square. Which of course, or 25 plus 16x square. So that is the hypotenuse. And then so tangent is that. Actually, we don't even need to go back to this. We just keep it in terms of y. Even better. Now secant of y. Secant is reciprocal of cosine. Cosine is adjacent hypotenuse. So just say 1 over cosine adjacent over hypotenuse So it will be hypotenuse over adjacent. So we have square root of 25 plus 16x squared over adjacent is 5. Right, then we can substitute that back in here. Again, we don't even need that. So derivative is equal to 4, 5, and then square root of 25 plus 16x squared. The bottom is 5 square. We do have the square outside here. Now, we will square the top. Square and square root cancel out. 25 plus 16x squared. The bottom is 25. Right. So 5 and 25, that cancel. Just 5. Multiply reciprocal, we have 4 multiply 5 over 25 plus 16x squared. So we end up with 25 plus 16x squared. So we don't have to use the inverse function theorem, just work directly. But we have to use some trigonometry there. But that's what we have. Right. Next we have this. First we'll take the tangent on both sides. I'm sorry, cosine on both sides. Because cosine cancel the inverse. Right. So we have cosine of y equal to 9x squared plus 2. Right. Then differentiate with respect to x. So y is not x, so I put a parentheses around it. Derivative of cosine is negative sine of the parentheses, derivative of the parentheses. So that's standard chain rule. Derivative of 9x squared plus 2, that's 18x. Right, inside the parentheses y. Now we asked to find derivative of y, so we're going to get this by itself. So divide by negative sine y on both sides. So we have y prime equal to 18x divided by negative sine y. So negative 18x over sine of y. Right. Now we're going to draw a triangle based on this. Cosine of y is equal to 9x squared plus 2 divided by 1. Cosine is adjacent over hypotenuse. So draw a triangle here. The angle is y. Up hypotenuse is 1. Adjacent is 9x squared plus 2. So the opposite will be square root of 1 square, still 1, minus 9x squared plus 2 square. Right. And then finally we need sine of y. Sine is opposite over hypotenuse. Opposite that. Hypotenuse is 1. So we just have that big square root. and then we substitute in for sine y. So y prime equal to negative 18x over square root of 1 minus 9x squared plus 2 square. Sorry. Right, so pretty much that. Again, for the inverse trig function, the function we cancel the inverse, and then we go from there. We don't even need to use the inverse function theorem. We do that, solve for the derivative, and then to get back to this, we have to do some trigonometry there. But that's all we do, and that's what we have for this review. I hope you found this helpful. Thank you for watching.